To give up, you have to be dead, or completely incapacitated.
Son. I drank the coffee already, let me make one more. Previously on Not Ready to Die but Are You Even Alive, son? Going down and up the protocol stack. OSI layers. 1 to 7. Application, presentation, session, network, transport, data link, physical. PDUs. Do sergeants pay for beer? Data, segment, packet, frame, bit. Or better yet, Don Sun Pon for Bon. What is this? Ha. French a lot. Don Sun Pon for Bon. Amazing. Encap decap. Encapsulation decapsulation. As you can see, there is a lot going on this shy tea. One might say too much for the dumb man like you, my son. But I'll try to dumb this down to imbecile level so that even the blind man could see. By the way, I kinda failing for a little right now. But. Layers and communication. By the way, I should do some job, but damn son, why it is so hard. That what it is for people who don't do shy tea. It is easy but hard. You see? So. This communication thing is very complicated, and it is even more complicated in real life where hosts are on different networks, parts of the World Wide Web. Let me show you with my words as always. I have this power, as I told you many messages before. Trust me, I saw a lot of movies. Let's say host A wants to send data to host B. Notice that each device needs to process information at specific layers. For instance, once host A places its information on the wire, the switch connected to host A needs to process this information. Switches function at layer 2 of the OSI model. Whereas routers make path decisions based on destination layer 3 logical addresses, switches make path decisions based on layer 2 destination MAC addresses found in frames. Therefore, the switch's physical layer will have to convert the physical layer signal into bits and pass these bits up to the data link layer, where they are reassembled into a frame. The switch examines the destination MAC address of the frame and makes a switching decision, finding the port the frame needs to exit. The switch needs to forward the data to the router, so it then sends the frame down to the physical layer, where the bits of the frame are converted into physical layer signals. The next device in the food chain is a router. Routers function at layer 3, the network layer, of the OSI model. The router first converts the data, which is an electrical signal traveling the wire, into bits at the physical layer. The bits are passed up to the data link layer and reassembled into a frame. The router then examines the destination MAC address in the frame. If the MAC address doesn't match its own MAC address, the router drops the frame. If the MAC address matches, the router strips off the data link layer frame and passes the packet up to the network layer. At the network layer on the router, one of the functions of the router is to route packets to destinations. Router examines the destination logical address in the packet and extracts a network number from this address. The router then compares the network number to entries in its routing table. If the router doesn't find a match, it drops the packet. If it does find a match, it forwards the packet out the destination interface, the local interface designated by the router's routing table. For the packet forwarding, the router passes the packet down to the data link layer, which encapsulates the packet into the correct data link layer frame format. If this were an Ethernet frame, for example, the source MAC address would be that of the router and the destination would be host B. At the data link layer, the frame is then passed down to the physical layer, where the bits are converted into an electrical signal at the physical layer once again. When sending traffic between two devices on different segments, the source device has a layer 2 frame with its own MAC address as the source and the default gateways, router, MAC address as the destination. However, in the layer 3 packet, the source layer 3 address is the source device and the destination layer 3 address is not the default gateway, but the actual destination the source is trying to reach. For the exams, remember that layer 2 addresses are used to communicate with devices on the same physical or logical layer 2 segment/network, and layer 3 addresses are used to communicate with devices across the network, multiple segments. Another way to remember this is that MAC addresses can change from link to link, but layer 3 logical addresses, by default, cannot. Note that routers separate physical or logical segments, while bridges and switches don't. Therefore, if PCA wants to send traffic to PCB, PCA uses the router's MAC, or layer 2, address to get traffic to the exit point of the segment, but it uses PCB's logical, or layer 3, address to tell the router that this traffic is not for the router but for a machine on a different segment. Next device that receives these physical layer signals is the hub. Keep in mind that in today's day and age that is most likely going to be a switch, but I wanted to have a hub in to discuss how hubs handle data. Hubs and repeaters operate at the physical layer. Basically, a hub is a multiport repeater. It repeats any physical layer signal it receives. Therefore, a signal received on one interface of a hub is repeated on all of its other interfaces. These signals are then received by host B, which passes this information up the protocol stack. We used switches instead of hubs because hubs send the data, the electrical signal, to all ports, while a switch would filter traffic by only sending data to the port that the destination address is connected to. Boring bish. I'm Don the Ti Don T and need to know this low-level earthworm type of stuff, show me the money son. Ha. Anyway. Today I will be going to that gym where the grills were checking me out with my new haircut and new t-shirt. You trying too hard son? Ha. And then maybe cinema? Maybe. You trying so hard but Don T actually want nothing to do with the grills. You strange son. Or dumb? Which is it? I buy.